Welcome back to Learn with me, Ms. Killen, here at MPB. We are in our 9th unit. We are looking at functions, linear, quadratic, and exponential. We're reviewing them. So we want to make sure that we've got all that covered before we go into anything new. So let's look. We're looking at lesson 3. We are knowing the difference between geometric and arithmetic or arithmetic. I can determine which sequence is being used by reading the real-world models. We're looking at F-IF.3 and LE1, A, B, and C. So let's go ahead and remember. Now, I'm not saying learn for the first time, I'm saying remember, because we've already gone through both of these sequences. So we just need to make sure we're remembering what we've learned. So our general formulas for a geometric sequence is a sub n equals a sub 1 times r to the n minus 1. Our arithmetic sequence is a sub n equals a sub 1 plus n minus 1 times d. So we've got those different general formulas. We just want to make sure that we remember them so we can see what we use and how we use them in these sequences. So here we go. So it says, in geometric sequences, so I have a common blank is what you see between the consecutive terms. So we said we had a common ratio. And then it says, what type of pattern does it follow? It follows, for geometric, exponential. And then what type of graph is used to show this geo sequence? We either have a growth, which is increasing, or we have a decay, which is decreasing. So we want to make sure that we're remembering what those growths look like or what those decays look like. That's our geometric sequencing. All right, so here we go. So our arithmetic or our arithmetic sequence, we had a common what with it? We had a common difference. And then we said we had a blank pattern is followed in these arithmetic sequences. We have a linear pattern. All right, and it says a blank graph shows an arithmetic sequence, and that's going to be a straight line. So we have all these different components, all these different characteristics of these sequences that we've got to make sure that we're understanding and remembering. All right, so here we go. It says, question, for both sequences, our domain can be described how? How are we describing them? Well, we said that we can describe them by a subsets of integers. We want to make sure that we remember that. They are subsets of integers. Good job. All right, so let's do some practice. Now, this is a Mississippi Department of Education practice that you would see on that MAP practice test that you can find online. So I want us to see if we can work this type of problem. So let's go ahead and read it. It says, James deposits money into 2 different savings accounts. The table shows the balance in each account in 15 months intervals of time. All right, so we have our months, 1, 15, 30, 45, and 60. Then we have our account balances, which is $25, $26.50, $28, $29.50, and $31. And then in account B, we have $25, $29.02, $33.70, $39.12, $45.42. Now, Ms. Killen, why did you go and read all of those different numbers, all of those balances? Because you have to analyze your graph to get all the information you can. Just like we annotate our passages, you have to annotate or analyze those graphs or those tables. All right, so let's look at the questions. Which function best models each account? So which one would we say is linear and which one would we say is exponential? So if I look at this first account, what do I do to go from $25 to $26.50? I am adding $1.50. So then what do I do to go from $26.50 to $28? I am yet again adding $1.50. So from $28 to $29.50, you guessed it, I'm adding $1.50. And to go from $29.50 to $31, yep. So obviously account A is what? It's linear. So let's put that. So I'm going to put account A. All right, so just to double check, let's make sure account B is exponential. Let's look. All right, so to go from $25 to $29.02, what did I do? Well, it looks like I added $4.02. And then to go from $29.02 to $33.70, well, let's see. What is that? Or what am I multiplying or dividing? So let's see. I have $33.70 and $29.02. Well, that is $4.68. So if I have $33.70 and I have $29.02, which we did that one, I needed to do, yep. So then I had $39.12 minus $33.70, which was $5.42. And then I had $45.42 minus $39.12, and I get $6.30. So obviously I'm not adding anything. So how could I possibly find what I'm doing here? Good, let's try it. Let's try division. All right, so I'm going to erase these and go back and see if we can try division. So let's say that I take 29.02 and divide it by $25. I get 1.16. All right, so then let's take 33.70 and divide it by 29.02. I get 1.16. So then let's try 39.12 and divide it by 33.70. I get 1.16, and let's just double check 4542.42 divided by 39.12. So I am changing by 1.16. Obviously that is my exponential. So I'm going to put account B. So then it says, based on the account balance information, which statement is true? Account A and account B both increase by an equal factor. Well, I know that's not even true, so I'm not even going to finish that one. This is not the answer. Okay, so let's look at B. Account A and account B both increase by equal differences. Well, they're not equal. So it says account A increases by an equal difference and account B increases by an equal factor. Remember how we had to divide? So that could also look at multiplying by a factor over the same amount of time, possibly. Account A increases by an equal factor. Well, I didn't multiply with account A, I added. So that's not my answer. So my obvious answer is C. See how we went through them and looked at each individual to see if it was true or if it was false. That's how we can truly get through these type of word problems, if we're annotating and we're analyzing. All right, let's go. All right, so this is time for you to master. Make sure you completely read the answers just like we did. All right, which of these scenarios could be modeled by graphing constant percentage rate per unit? So you and your table partner, take a few minutes, pause the video, go ahead and answer these questions, come back to me and we'll see what we got. All right, I'm going to read them first and then we'll see if they are changing by a constant percentage rate. Mina reads 85 books each night before bed. That's an important word. Landon drives 27 miles to Walmart once a week. Okay, 27 once a week. Royal saves 13% of his paycheck each week for vacation. Okay, saves 13% each week. That's important. The total number of subscriptions to Math Today is increasing by 2.43% each month. All right, increasing by that each month. So let's go by these one at a time and see what we've got. Let's start with Mina. Let's say, okay, so each night, so Monday night, she's got 85 pages. Tuesday night, she's got 85 pages. In 2 weeks, Tuesday, she's got 85 pages. So I could say that's linear. That's not going to be a constant percent change. So I know Mina is not the answer. Landon drives 27 miles to Walmart once a week. So every Tuesday at 4:15 in the afternoon, Landon's hitting his 27 miles to Walmart to and from. Okay, that is a constant rate. Every week, every Tuesday, 4:15, 27 miles. So that's not the answer. So now, Ms. Killen, I see two percentages. So I'm going to say it's between Royal and Math Today. Well, I would say that too. So let's look to see how we're changing to see which one is going to be the answer. Let's start with Royal. So let's look. He saves 13% of his paycheck each week. Now, we're taking into consideration that he gets the same amount of paycheck. So let's say that his 13% would be $27. So the 13% is $27 each week. So that's going to be the same amount each time we see how much he's putting into his savings. So I'm not thinking it's Royal. So let's go down here and look at Math Today and see what we can find out about it. Here we go. The total number of subscriptions to Math Today is increasing by 2.43% each month. So let's say that the first month I have 100 subscriptions. So then I'm adding 2.43%, and then I have a new amount. Then of this new amount, I am adding 2.43%, and I get a brand newer amount. And then for that brand newer amount, I'm adding 2.43% of that. So if I wanted to know which one has the constant percentage rate per unit, I'm going to say it is Math Today. So if you got Math Today, good job, guys. So see how we went through each scenario and said, I'm doing this to go to my different points. That's what you have to do sometimes. Because between Royal and Math Today, you really had to go and say, okay, so if this is how much Royal's getting each paycheck, then I'm adding that amount, that same amount. So it's not a percentage, it's just a percentage of his paycheck. Now, with Math Today, I'm going up from 100, I'm rising or increasing 2.43, and I get a new amount. Then I take that new amount and I get 2.43 of that new amount to go up. And then I get a newer amount. And see how I'm doing that? So depending on what my next point is, depends on what my previous point is. Good job, guys. I want to make sure that we don't forget how to put the formulas for sequences in our calculator. Now, we've gone over this, how we plug them in our calculator, how we use those different features on that calculator. Remember, there's always that calculator lesson that you can review if you need to, so don't forget that. And then we have to make sure that you're reading the real world scenarios before you answer the questions. You've always got to see what you're talking about before you can get an answer. I'm so glad that you're learning here with me in MPB. I'm having a great time reviewing these functions. I want you to have an awesome day.